Welcome to BSc Statistics students. In this class, I explain one of the problem in matrix oddment method for n by n games. For any particular method, for any particular game to apply any kind of method, before that you have to check whether the saddle point exists or not. Now we calculate saddle point. Row minima 1, second row minima 3, maximum 3. This is mu underscore maximin. Column maxima 5, column maxima 4. Minimum among these, it is 4. So it is minimax. Therefore, maximin not equal to minimax. Hence, saddle point does not exist. Therefore, you have to apply any one of the method. Here in this class, I explain matrix oddment method. Matrix oddments, which for which what you have to do? You have to calculate first of all. This is what A you have to consider. I am considering A here. A is equivalent to be 5, 1, 3, 4. And from A you have to calculate at very first you have to calculate C, the new matrix C, which is nothing but what we want to do is you have to calculate first column minus second column. The C matrix is obtained by first column minus second column. Then you will get what is first column? It is 5, 3. Second column 1, 4. So 5 minus 1 and 3 minus 4. It is this much simple to calculate. 5 minus 1, it is 4. 3 minus 4 is minus 1. Now immediately you have to calculate C1 and C2. Determinant of C1 and C2 also. The C1 is nothing but the value of C1. By deleting first row from the C1 and C2, we will get row oddments. From the C, from the matrix C, we can obtain row oddments. Okay. For 4 and minus 1, C1 is nothing but by deleting first row, the remaining value, for the remaining values you have to calculate determinant. But of course only single element we have. C1 is equal to minus 1 by deleting the first row. And C2 is equivalent to be by deleting the second row. C2 by deleting second row, the value of the remaining, that is 4. So determinant of C1, obviously determinant of C1 is nothing but minus 1. Determinant of C2 is also 4. Determinant of C2 is 4. Determinant of C1 is minus 1. So because only single value, determinant is same. Now coming to the R, that is row matrix. To calculate the row matrix R, again same procedure you have to do. First row minus second row. First minus second rows. What you will get? First row 5, 1. That is second row 3, 4. So 5 minus 3. 5 minus 3 and 1 minus 4. 1 minus 4. So it is equivalent to be 5 minus 3, it is 2, 1 minus 4 is minus 3. So now it is one particular row matrix which consists of 2 columns. Right? I have already explained in the procedure that if you have a 2 by 2 matrix, then this will be column matrix will be 2 by 1, 2 rows 1 column. R will be 1 by 2. One particular row will be reduced. In the column matrix, one particular column will be reduced. Here are 2 columns, here only 1 column. Here are 2 rows, and in A 2 rows, in R only 1 row. So okay, now R1 is nothing but what you have to calculate the magnitude of column oddments. To get the column oddments, you have to calculate R1 and R2. R1 is nothing but by deleting first row, by deleting the first column, because of column oddments. By deleting the first column, remaining value is -3. And R2 is by deleting second column, that is you will have a value 2. Therefore, now oddments, which that is determinants. First of all, determinant of R1 is equal to -3, determinant of R2 is equivalent to be +2, that is 2, because single elements. Now row oddments and column oddments. From the C you will get row oddments. You will get row oddments. From the column you will get column oddments. The row oddments are determinant of C1 is equal to -1, determinant of C2 is equal to 4, which are row oddments. First row for second row, oddment here, -1, 4. Oddment means magnitude of the oddment is -1 here, 4 here. And similarly now the column oddments, determinant of R1 -3, determinant of R2 it is +2, which are nothing but column oddments. Clear? Now what we have to do is you have to formulate an augmented matrix. It is called augmented matrix, which meant by you note down the values of the matrix, that is 5, 1, 3, 4, and against to that you have to write modulus of row oddments against to rows. Row oddments. Modulus means you have to consider this, whichever the oddments value of oddment we get, we have to ignore the sign of the argument, sign of the oddments. Similarly, modulus of column oddments. Modulus of column, modulus of row oddments. Row oddments here -1, 4. So +1, +4. We have to consider only positive sign. Column oddments -3, 2. Therefore, which are +3, +2. Right. Now you add the, after calculating the modulus of row oddments and modulus of column oddments. Now check whether the sum of the row oddments equal to sum of the column oddments. Sum of the row oddments 4 + 1, 5. Sum of the column oddments 3 + 2, 5. So therefore, which are equal. Then we can do this procedure. We can apply this procedure, this method. In this method, we can calculate the optimal strategies and value of the game. Now, how to calculate the optimal strategies? The optimal strategies for player A. Now I write here. Optimal, first point. Optimal strategies for player A. For player A. And second one, optimal strategies for player B. And third one, value of the game. These are the 3 points you have to calculate. Now we can calculate by using just simply the oddments that now which are to be expressed as a percentage of total. For example, row oddments, you will get P1, P2. Here I write P1 is equal to, it is one particular chance out of 5 chances, that is 1/5 the probability. P2 is 4 chances out of 5 chances, 4/5. That is to use the second strategy. For example, if you write A1, A2 here, to use the strategy A2, to select the strategy A2 of player A will be more. That is what oddments express. So our row oddments are to be expressed as a fractions of the total, which gives you the optimal strategies for player A and player B. So P1 is equal to 1/5 and P2 is equal to 4/5, which means optimal strategy of player A, SA is equal to A1, A2, which is 1 by 5 and 4 by 5. Clear? This is the way to calculate the optimal strategies for player A. Similarly, here out of every 5 chances, 3 chances for selecting the strategy B1 for player B, and B2 for every 5 out of every 5 chances, 2 chances, 2 by 5. So therefore selecting the strategy B1 is more for player B. Probability is more, 3 by 5. The fraction we have considered. The chance will be more. So therefore, from the Oddments method, from the above augmented matrix, that is, if you format augmented matrix, you will get remaining all optimal strategies for player A, player B, and the value of the game. The Q1 is 3 by 5. Q2 is 2 by 5. So therefore, optimal strategies for player B, total number of strategies for player B are B1, B2. Therefore, with the probabilities 1 by 5, not 1 by 5, 3 by 5 and 2 by 5. So player B maximum uses selects the strategy B1. Player A maximum selects the strategy A2. This is what our prediction. That is optimal strategies for player A and player B. Now the value of the game. Value of the game, just by taking with these fractions, by taking any row or any column. I will tell you 1 or 2. So by using second column, for example, then you have to use these particular probabilities. 1 into 1 by 5, the value of the game by considering second column. 1 multiplied by 1 by 5 plus 4 multiplied by 4 by 5. 4 by 5. 16 plus 1, 17 by 5, your answer. Similarly, this is by using second column, by using B2, second column. Now I calculate same thing with one more. For example, A1, first row. We can consider any row or any column to calculate this. First row, 5 and 1. We have to multiply. That is expected value of the game is going to be multiplied, is going to be calculated by using the formula summation x into p of x, right? 5 into 3 by 5 plus 1 into 2 by 5. If you use this, 5 into 3 by 5 plus 1 into 2 by 5. Is it clear? Right. Now you calculate this. 5 3 is 15, 2 1 is 2. 15 plus 2, 17 by 5. Is it clear? This is by using first row. Any row or any column you can consider with respective probabilities. If you use this particular row, the probabilities are these: 3 by 5, 1 by 5, 2 by 5. If you use, for example, B1, you have to multiply with 1 by 5 and 4 by 5. These probabilities. 5 into 1 by 5 plus 3 into 4 by 5. 4 3 is 12, 12 plus 5, 17. 17 divided by 5. Right. So this is what the method to calculate the optimal strategies for player A and player B and value of the game from this augmented matrix. So this is what the method of Oddments. For this only can be done for n by n games. That is square games, square matrix. Both the players having same number of strategies. Right? So for any given particular game, you have to calculate oddments, column matrix, row matrix. From the column matrix, we will get the row oddments. From the row matrix, we will get the column oddments. And then you have to calculate modulus of row oddments, modulus of column oddments, and you have to put against the rows and columns, and you have to obtain augmented matrix. From this augmented matrix, you can determine remaining optimal strategies for player A, player B, and value of the game. This is the methodology to find a particular problem, to solve a particular problem by using matrix oddments method. Thank you so much.